if A and B are some numbers, then I would have to say to the reader of the program that they are numbers of the type double. Now, A is a number of the type double or a value of type double, and so is B. What is this double? This double is a qualifier which tells the reader that A stands for some arbitrary real number. In the general case, this is not really true, but for the time being, it's okay of a definition. You can safely think of A as any real number, and the same as of B. You will also remember that in geometry, practically every formula is expressed as an algebraic expression. So, were we to write down the formula for the area of a rectangle, we would write, for example, something like this. A times B, where A and B are the sides of the rectangle. So what I would like to do now is write a program that will compute the area of some rectangle that we imagine. And to do that, we will have to use these variables that I have just introduced. So I'm going to write the whole program down, beginning with the main function. int main, open paren, close paren, open brace. Now I have to define our two variables, two symbols that we will be using. Double A. And what I will do now is state immediately, upon having introduced the symbol A, what it stands for. So let A be 4. That's one side of our imaginary rectangle. And let B be 3. And let's print out now what the area of this imaginary rectangle is in a way that somebody viewing just the result will understand what the program was all about. I'll be needing some space, so I'll erase this stuff here. And I write C out less than the area of a rectangle with sides A equals double quotation signs less than. Now we have to tell what A stands for, and that's the value of this symbol here. A. And now I'm continuing the message, and B equals, again I have to say what B stands for. And I run into a mild problem. I ran out of space. C++ allows us to statements to span multiple lines. So what I'm going to do is to continue this statement here, like this. And I write down the expression for the area of a rectangle. Less than en dl. One thing we have to pay attention to when spanning statements along multiple lines is that we don't do the same to a string. It's illegal for strings to span multiple lines. Statements are allowed to do that. Actually, there even is a cure for spanning strings multiple lines, but let's pretend that there isn't for the time being. And that's the whole program. So I can close the brace and finalize it. Let's see what it does by executing let standard output be this piece of the whiteboard. And we'll need one additional thing other than the standard output. We'll need a place to store the values of these symbols. And that place is called the memory. And I'll write it down here. Let this be our memory. Starting with the first statement in our program, we see that it's an introduction of a variable, a, of type double. So it stands for real values, real number values. And it's immediately specified what the value of that variable a is. So we write it like this. The name a, and a container to put the value in. An empty box. And then I write down 4, which is the value specified. Next statement does the similar thing. Introduces the variable b, which also has a container associated with it. And that container is populated by the value 3. Finally, the last statement in our program is this printing out the result on the standard output interface. And we proceed as before in this order. So we write down the string, the area of a rectangle, with sides a equal. The next thing we encounter is an expression. This is an algebraic expression, a trivial form of an algebraic expression. What does it evaluate to? It evaluates to the value of this variable. And we can see its value in the memory. Its value is the number 4, whatever that number is. So we write down 4 on the standard output. And we continue. Next thing we encounter is a string. And I write down and b equals. What does it equal? It equals to the value of the variable b, which is written in the memory to be 3. And then we proceed to the next line and a position here. We have a string is. And finally, we have to evaluate this expression. How do we evaluate? By substituting the values for a and b. So this expression is turned into this expression. 4 times 3. And it evaluates to 12. And that's what gets printed out. 12. And we have the ENDL magical word, which instructs us to proceed to the next line here. And since there are no more statements to this program, we are finished with it. So this is a program that calculates the area of an imaginary rectangle. There is one issue with it, and that is the case that if we were to specify a different rectangle, for example, if we want to compute the area of some other rectangle, what we would have to do is change the values of these 2 variables. So to calculate an area of a different rectangle, we have to write an altogether different program. Wouldn't it be nice if we had a single program which can calculate the area of any rectangle it makes sense to calculate the area of? Well, the answer is yes. And it turns out it's not hard to do that. The missing piece of magic is a way for our program to read information from the outside world. And the way programs do that in C++